This is part 4, test 1, review chapters 1 through 4. So I put this data into my calculator, into edit. I put it in L1 and L2. To look at the data, I press second Y equals. I make sure my stat plot is on. I pick scatter plot. I tell it list 1 and list 2 wherever I put my X data and my Y data, and then I can press zoom 9. And I can see that the data looks like this. I can sketch it onto my paper. And it does appear somewhat linear. And it would be a positive linear. To get my equation, I would go stat, calc, 4. I have to tell it list 1 and list 2. And my R's did not show up. To get my R to show up, I go second, 0, x to the negative 1. And that just brings me to the D's where I can find diagnostic on, hit enter. So I'm going to pull up the linreg again, L1 and L2, and now my R's are showing. So I'm going to go to about 3 decimal places. So that would be y equals 0.102 x plus 94.264. My R is 0.9114. My N is 1, 2, 3, 4, 5, 6, 7. I have 8 pieces of data. I can find my critical value. Table, here it is, table 2. Critical value for 8 is 0.707. So is there significant correlation? Yes. What might a person with 3,000 feet squared expect to pay in taxes? So that's telling me that if my X is 3,000, I can put this into the equation and find out what my taxes will be. So 0.102 times 3,000 plus 94.264, and I can see that it's going to be about $400. Okay, this is using this formula, and it says the 3 column to find standard deviation, label the empty columns appropriately. This is x minus x bar. I couldn't find it on the computer. So first we've got to find the mean. And to find the mean, we can put it in our calculator. So that would be 3, 4, 6, 12, 14, 20, 21, 24, 26, 31. Oops, 31. Okay. So stat calc 1. I see my mean is 16.1. So here I'm going to say 3 minus 16.1 4 minus 16.1, 6 minus 16.1, 7 minus 16.1, not 7, 12, 14, 'There's a neat trick in our calculator. If we go back to edit, if we go up to L2 and we do second L1 minus 16.1, oops, there it is, 16.1, then it will put what our answers are into L2. If I want to square the numbers in L2, I can go to L3 and go L2 squared, and I will find these numbers. So this is negative 13.1 squared. There's also a way to find the sum of L3. The only way I know to get there is to go to second catalog and S and find sum and then put L3 in there, and it's 862.9. So the sum of this column is 862.9. And the standard deviation is 862.9 divided by n, which is 10 minus 1. Oops, that's this down here. Which is 9.79, and then if we square that, we get 95.84. So our standard deviation is 9.79, and our variance is 95.84. And we can see that, yes, our standard deviation was 9.79 from our calculator on our one variable statistic.